Okay, we're going to do a few problems here on page 728, the Chapter 7 review. We'll start with number 7 here. We have to solve for both x, y, and z, so there's really kind of three problems here. For x, these are angles, and first of all, these are two similar figures. These look like trapezoids, but they're similar trapezoids. Angles are flat out the same, so this angle right here, where the 3x is exactly the same as this angle here. Even though the figure is bigger, the angles are still the same. So we got to know what this angle is. If this is 100 and together it makes a straight line is 180, so this would be 80 degrees. Again, that's 180 minus the 100 on the other side, which makes this 80. So 3x is equal to 80 degrees, and you could simply solve for x there. To solve for y, we are going to use proportions here. We're going to say big trapezoid to small trapezoid, y to 2. So we're going to say 12 on the bottom to 4 on the bottom is equal to y, the up and down line, is to 2. And then you would simply cross multiply this and solve for y. So it looks like y is going to be 6. And then once you have y is 6, you use this, plug it in here. 3 times 6 is 18 minus 2. This would be actually equal to 16. And then you would do the same to help solve for z, using this 16 to z. So again, you can go 12 to 4 is 16, after you plug in the y value, is to z, and then you would solve for z. All right, now we're going to take a look at number 8 here. We have both an x and a y. We see this 4.5, we see the 3, we can say 4.5 to 3, and then we can go bottom 5x to y. So if you go 4.5 on the big triangle to 3 on the small triangle is 5x to y. That's kind of the setup. The problem here is if you cross multiply and you got an x and a y, that's a huge problem. So we've got to figure out what either x or y is first to help cross multiply this. You can't solve two variables with one equation. And the way we're going to do this is a bit different. We are going to flat out ignore this triangle here on the left and just look at the fact that this is a right triangle. We can go a squared plus b squared is equal to c squared. We're just going to flat out solve for y. And once we know what y is, we would use that number to help solve for x. So the square root of 40, which is about 6.32. So in this original problem, 4.5 up and down to 3 up and down 5x, and then instead of y we're going to put in what y value is 6.32, and then cross multiply to help solve for x. Okay, now we're going to take a look at number 10 here. We've got two similar triangles. It doesn't look like it's going to be a hard problem here. However, we have to solve for both x and y. We can say we have a 7 here, we have a 3.5. 7 and 3.5, really this is 2 to 1. So this figure is 2 times bigger than this one. So instead of 7 and 3.5, I'm going to use 2 to 1. 2 to 1. So we can say 7 to 3.5, again that is 2 to 1. 2 on the big, 1 on the small, is like x plus 4 to y. Now you'll notice right off the bat, there's an x, there's a y. If I cross multiply this, this is 2y is equal to x plus 4. You cannot solve two different variables with one equation. You need two equations if you have an x and y. So we're going to create the other equation. Again, it's 7 and 3.5, but I'm just going to go 2 to 1. 2 to 1 is equal to 3y compared to x, the bottom leg compared to the bottom leg. Cross multiply this, you get 2x is equal to 3y. Now you've got two equations with two variables, and now you have what is called systems of equations. So we're going to use both equations to help solve for x and y. I'll get this x by itself, so I'll minus 4 over here. So this is 2y minus 4 is equal to x. Well, what do I do with this 2y minus 4? Since I know what that is, what x is equal to, I'll substitute it right there. So instead of 2 times x, it is now going to be 2 times 2y minus 4 is equal to 3y. Again, I'm doing a substitution. This is all algebra here, so hopefully this comes back fairly quickly. And I did my distributive property. I will add this 8, now minus this 3y, add the 8 minus the 3y. This is y is equal to 8. So y is equal to 8. And then, of course, you use that value and figure out what x is equal to. I'll take this first equation here. And again, it doesn't matter which equation, because this value for y in either equation will solve for, oops, this is not plus 8, it's plus 4. Plus 4, plus 4. Anyway, put in the 8 there. That is 2 times y, 2 times 8 now. This looks like it's 16 is equal to x plus 4, so it looks like x is equal to 12. X is equal to 12, y is equal to 8. Systems of equations. And again, most of this is algebra, but from the beginning it was 2 equations. 7 to 3.5, x plus 4 to y. Need another equation, 7 to 3.5, 3y to x. Then solve the algebra. Okay, number 19. We start off with a right triangle, and then from the 90-degree angle we draw an altitude, another 90-degree line to the hypotenuse. What happens here, it splits it into 3 triangles, the one on the left, the one on the right, and the big original one. All 3 triangles are going to be similar because they do all share the same angles, and when you have 2 of the angles that are the same, you have similar triangles. They all have a 90-degree angle, and I like to use colors here. So I'm going to put this as a red dot, a red dot, a red dot, this being the blue dot. I don't know how this would be a blue dot here, and this is a blue dot here. I like to use the colors to help figure out comparisons. So I'm going to go red dot to the 90 degrees, red dot to the 90 degrees, blue dot to the 90 degrees is the blue side, blue dot to the 90 degrees is the blue side. And then if this is the blue angle and 90 degrees, this has to be the red angle. If this is the red angle with the 90 degrees, this has to be the blue angle, because all triangles add up to 180 degrees. They all share 90 degrees, they all share a red and a blue angle. Again, I don't know what the degrees are, but it doesn't really matter. Okay, so this visually shows that the 3 triangles are similar to each other, and we're going to solve for both x, y, and z. We're going to set up 3 different proportions to solve for each one. Let's solve for x. Now there's 3 triangles. You're only going to pick 2. So which 2 do you really pick? Well, you're going to solve for x. So notice this triangle here, y, z, and 4. This one doesn't even have the letter x, so I'm just going to block it out. So you're using the small one on the left and the big original one. And if you look carefully at x, it's the hypotenuse here, opposite the 90 degrees, hypotenuse there. So that's in yellow. So what I'm going to do is go to solve for x, hypotenuse to hypotenuse, yellow to yellow. And then I'll also go, this x is on the red, so I'll go red to red. So yellow to yellow is equal to red to red. And this being a red side, and this is a red side. Okay? By the way, this, if I use this middle one, that would be the hypotenuse in yellow. Okay, so cross multiply that and solve for x. Let's solve for y. You got 3 triangles to choose from. We're going to get rid of, we're only going to use one. This one here, x, z, and 5, doesn't have a letter y, so I'm going to block that out. And I will say, what is y on? Y is on blue and red, so I'm just going to say blue to blue is equal to red. And then we'll cross multiply that. So I'll say blue to blue is red to red. Cross multiply that small. Blue on the small, blue on the big, red on the small, red on the big. Okay? And finally we do, and then again I'm assuming you can cross multiply that and solve that. Finally we deal with z. Well, there's a z, there's a z. This guy doesn't have a z, so I'm going to take that out. Again, my z's are on yellow and blue, so I will just go yellow to yellow, blue to blue, and then of course cross multiply that and solve. So yellow z to yellow 5, blue 4 to blue z, and cross multiply and solve that. All right, so this is a visual challenge. You know you have 3 similar triangles. You've got to, because the triangles are not pointing the same way, it makes it really difficult. I use the colors to help guide you through it, and then cross multiply once you have the setup.